Well, in this video, I'm going to talk about the second objective that's in the power focus area, which is solving equations. And once again, this does not replace all the practice and learning that you can do. I cannot promise you that this is the only video you watch and the only practice you do that you're going to be able to pass, but I hope that this is helpful as a review and perhaps what you need in order to conquer this content assessment. The basic steps that you need to remember when you're trying to solve equations are that you need to make sure to isolate the variable. And so that's the whole goal. So make sure to work on the side that has the variable. There's no point in working on the side that doesn't. Sometimes the variable will be on the right side, and you want to make sure to still work on the side that has the variable. And what I mean by work on it means getting rid of all the numbers which are surrounding your variable one at a time in reverse order of operations. That means first you take care of things which are adding or to or subtracting from your variable. Then you do things which are multiplying or dividing your variable. And finally, things that share an operation inside of a parentheses with your variable. Even if it's adding or subtracting, you do that last because it's inside of parentheses with the variable. Now, to get rid of numbers, first ask yourself, what is the operation that the number is doing to my variable? Is it adding to it, subtracting from it, dividing it, or multiplying it? And do remember that if you see a fraction, that's the same thing as dividing it. Then you get rid of that number by doing the opposite operation to both sides of the equation. Important to do it to both sides so that the statement remains true, so that the truth of the equation is the same and the equation remains balanced. As long as you do it to both sides, nothing changes. Then repeat that process one step at a time until your variable is isolated and you have an answer. Then it's wise to get that answer and plug it back into the original problem like you're trying to evaluate an expression. And that's why I made an extra video that included that, because it's a good practice to actually do that. And follow the order of operations one step at a time until you see the final result that it should be that both sides of your expression, of your equation, actually match. And if that's true, then you did a good job. Now, don't forget to do this in reverse order of operations, and that addition is the opposite of subtraction, and multiplication is the opposite of division when you're trying to get rid of things. There are a couple of examples of this here on the screen now, but if you like to pause the video and look at them, that's great, but I'm going to do a few practice problems anyways in the worksheet, and so hopefully that will be helpful for anyone who's trying to remember how to do this. So here we have the first example, which is 4x minus 9 equals 11. I like to circle the things I need to get rid of, and since I have to start in reverse order of operations, I have to start by getting rid of that negative 9. Do remember to pause the video before I solve a problem so that you have an opportunity to practice and learn more that way. And then you can see each step of the way if you're doing it the same way I'm doing it. All right, so then I'm going to add 9 to both sides because that's how you get rid of a negative 9. And you have to do it to both sides. So you do it the opposite operation of subtracting, which is adding. Once you do that to both sides, when you do that, the negative 9s cancel out on the left side of the equation, and then you are left only with 4x. And then on the right side of the equation, you have 11 plus 9, which is 20. All right, so we managed to get one number out of there. We got to get the 4 out of there next. So I'm just change color here so you can see the second step in a different color. So I got rid of that 4, and I asked myself, what is the 4 doing to my variable? And it's multiplying it. So when there's no sign, multiply. Don't forget that. So the opposite here would be dividing both sides by 4. So that's what I'm going to do. If you divide both sides of the equation by 4, then you should have your final answer, because 4 divided by 4 will cancel out because it becomes 1x. And 20 divided by 4 is just 5. And there is your final answer, x equals 5. Now, if you are trying to figure this out on the actual content assessment and you have a multiple choice, now you just look for an answer that has that. But you can also check to see if you're right by plugging that 5 into the original expression and seeing if it actually gives you the answer you're looking for. So if you do 4 times 5 minus 9, are you going to get 11? Let's see. 4 times 5, multiplication has to come first, gives you 20. And 20 minus 9 is indeed 11. So that means that you've done it right. Both sides are the same. It checks out. Now, why do I mention this plug-in step also? Because if you're doing this as a multiple choice, you have a second option to solve these problems. What you can do is look at the answer choices and plug it in one at a time until you find one where both sides of the expression actually match. So that means, for example, that if you have another option that was 3, another option that was -5, say another option that was 4, another option that was -3, and then an option that's 5. Of course, once you solved it, you can go into that option and say like, yay, that works. But you could have also, from the start, take turns plugging in one number at a time into the expression and seeing which one worked. Obviously, only the 5 would have worked. So another way to actually conquer the objective 2 of this test is not solving the equation at all, but going one step at a time and evaluating each of the unnumbered choices given. And if each choice checks wrong, then you know that those are not it. And the choice that actually works will be the one that you would have gotten anyways if you had solved the problem. So that means you can actually pass this test without ever solving an equation. You can just check all your answers, unless there are problems that ask you to actually put the equation, the actual answer yourself, and there's no multiple choice offered. But every time you do have multiple choices, you have that option to actually plug in the choices into the expression by substituting the actual letter with the actual number in the choice, and then working it out like we talked about in the expression video, and seeing if that actually checks out, if both sides are the same. And even if you do solve it, I would strongly recommend that you do the check step, because that way you can be fairly certain that you did it right. All right, the next problem has something that I would like to remind you guys. It's a hint that you have to remember when you're trying to solve such problems. And when you divide or multiply to cancel out a negative, you don't have to divide by just the number. You have to include the negative itself. Like if I'm trying to get rid of -3x, I have to divide by -3, not by 3. This also means, by the way, that if you divide by -1, you essentially just change the signs of your answer. So if you have negative x equals 4, that's the same thing as x equals -4. All right, so dividing by -1 just changes the size of both sides of the equation. Now, of everything on both sides of the equation. So let's see how these things show up in practice on this next example over here. So the first thing I have to get rid of here is this 6. Let me change the color so it doesn't mix up with the previous problem. So I'm going to try to get rid of this +6, and that's because it's adding to my variable. So I get rid of a +6 by subtracting 6 from both sides. Now be careful when you're doing this, because that's when rational number arithmetic becomes important once again, because you have to add two negatives together here. And if you're not doing that carefully, you're going to end up getting the wrong answer. But if you do, that's okay. As long as you do the plug-in step, you won't make that mistake. Now, if this is a multiple choice test, they're likely going to purposely give you an answer that is the answer that you would have gotten if you had made that mistake. So they don't pick those distracting answers randomly. They pick numbers that are numbers which are common mistakes. And so this is one more reason why you want to actually check your work, because I'm going to make a mistake on purpose here to show you what I mean. Anyways, if you subtract -6 from both sides, you actually get rid of the -6, and then x over -4 is still left on the left. And I'm going to make a mistake on purpose here. Let's say that you actually, I'm going to write this with a different color so that you remember that it's a mistake. Let's say that you actually do this and you get -0.5, right? Then if you try to continue solving the problem, you have to do the next step, which is to get rid of this -4 right here. Now, to get rid of a -4, remember, it's a negative number, so you have to multiply or divide by the actual negative number, not just by 4, but by -4. So I have to multiply both sides by -4 to actually get my answer, so I'm going to do that. Now, if you do that to both sides, on the left side, the -4 will cancel out the -4, because -4 times or divided by -4 is just 1, and all you have left is x. And on the right side here, if you do this, the negative times negative will cancel out, and the 2 is the answer you're going to get. Now, I'm going to write this in purple because, once again, I did the math wrong on purpose on this step here to show you what would happen if that's what you did. All right? So now I'm going to go back to my original expression to check my answers, and I'm going to do this in purple because this is the wrong check, okay? So I'm going to find that answer that I got, that it's 2 divided by -4, and then plus 6, and then seeing what I got. 2 divided by -4 is like half or -half, plus 6. -half plus 6 actually gives you 5.5 positive. So that means that is not negative 6.5, which means I did this problem wrong. Now, here's the reason that you have to do the check work. What if they had put 2 as one of the answer choices, right? Or maybe even 2 and then negative 2, all right? Maybe you would have made a mistake there. And why would they also include negative 2? Because maybe some students would have accidentally did it wrong on the last step here also. When multiplying the 2 negatives together, they forgot to cancel out the negative. So they picked these distractors, which are purposely picked to try to make you get it wrong. So to avoid that, you must make sure that you do the check step. If I had done this check step, I would have gone back and realized that, oh no, I made a mistake over here. That's not right. Let me see if I can fix that. Negative 6.5 added up to negative 6. They're both negative. You're supposed to put those numbers together. So if you put those numbers together, what you would have actually gotten is negative 12.5, which is a completely different answer that you would get. Let's see if I did that right, though. Maybe I made another mistake, right? And that, okay, so times 4, negative 4, the negatives will cancel out. And then 12.5 times 4 will give you 50. So let me change the color here. So that's the right answer this time. So if you get 50, would that be the right answer? Well, let's try to do a check step correctly here on the right and see what we get. 50 divided by negative 4, right? Minus or plus 6. So 50 divided by negative 4 is the same thing as 12.5 negative, which plus 6 is indeed negative 6.5. I get the same thing I need to get on the right side. So then I know I did this right. So this is the right answer. It's 50. Now, the answer choices would probably have that 50, and it will probably have something like a negative 50, and then some other number that is another common mistake that people usually do. I'm not sure what that would be right now, but my point is the choices aren't random, right? So if you don't check yourself, it's likely that you might get it wrong because they know the common mistakes that people make, and that's the choices that they pick, right? So you can avoid that in 2 ways. Either you don't solve it at all, just plug in one at a time into the expression to see if that's right, right? So if you had plugged the two, that would have come out wrong. If you had plugged a negative 2, it would have been, let's see, this would have been half plus 6, would be 6.5. So that would not checked off. It would be positive 6.5. So it wouldn't checked out. If you have to plug in the negative 50, you'd have gotten positive 12.5 plus 6, which would have been 18.5. So again, it would not have checked out with the right side. But then when you actually plugged in your 50, you would have gotten the answer right. And you'd be like, oh, that is the answer. So you always have the option to just plug in the choices into the problem if they're given to you and solve it that way. Or solve it like you're supposed to, but then make sure you check anyways, because remember, they're going to pick options which are going to look right on purpose because they know the common mistakes that people make. So don't just get an answer and jump to it. Actually check your work, and that way you will pass the test. All right, so that was pretty straightforward. This next problem also includes a negative number next to my variable, so there's going to be another one of these situations where we have to be kind of careful with what we divide by. And there's another thing that's interesting, which is that the expression is actually on the right side with the variable, but that's okay. I did this on purpose on the example because I wanted to show you that you don't always have to work on the left side. You work on the side that has the actual variable. And I have to start here once again by subtracting 6 from both sides because I'm trying to get rid of that plus 6. So if I do that and subtract 6 from both sides, I will get 33 on the left side equals, the 6's will cancel out, and all I have left is negative 3x on this side. Okay, so the next step I need to do is get rid of a negative 3. All right, so I ask myself, what is that negative 3 doing to my variable? It is multiplying, so I have to divide. But not by 3, because I'm trying to get rid of negative 3, not 3. So I divide both sides by negative 3. When I do so, my answer comes out to negative 11 on the left equals x on the right. So your answer should be negative 11. And again, that could be one of the answer choices that you could have found anyways by plugging in and making sure that that's the one that works. But even if you did by solving, I will still do the check step to make sure that's right. So on the side that has my variable, I rewrite the expression, replacing the actual variable with my answer. And then when I do that, I get negative 33 plus 6, which is, this is actually negative 11 that you're supposed to plug in. So you get positive 33 plus 6, which is actually 39. And so there you have it. That's how you actually figured out that you were actually right. And again, remember, they would actually pick choices on purpose that would be good distractors because they know the mistakes that people usually make. So just because you get an answer that shows up in the choices, that doesn't mean it's right. You should do the check step. All right. This number 4 has one more skill that I would like to remind you of, a hint that is useful, which is how to deal with parentheses. When you have a parenthesis, you have a couple of options. You can either distribute the parentheses and get rid of it. So, for example, if you have 3x minus 4, you can expand that 3x minus 4, right, in parentheses. You can expand that to 3x minus 12 first and then do normal 2 steps. Or you can leave the parentheses for less, like you're supposed to, in the order of operations. So if you do it that way, I find that there's less chance to make mistakes because you're going to make less steps. And so that's the way that I prefer to do it. I leave the parentheses for less. And by the way, I would also like to mention that if you have a situation like this, where it says x plus 4 divided by 3, and what you really have is a fraction that includes in the numerator variable and an operation, both sharing the same denominator, that is the same as having something in parentheses. That is the same thing as this. So this is like the same thing as 1/3 outside of parentheses times x plus 4 inside the parentheses. And if you were doing that, you would leave the parentheses for less. So that means that any situation where you have this kind of setup, where you have a variable plus a certain quantity or minus a certain quantity, all sharing the same numerator of a fraction, so they have the same denominator like this, that is as if it's written like that, all right, or like this. So it's they're all comparable ways of writing it. And in that, you would rarely see something like that, but if you do see it, that means you got to do that part less. So the first step you would have done here is to multiply both sides by 3 before, and then subtract both sides 4 from both sides to try to solve that one. But let's see how this looks like on this problem, number 4. And then we also have a number 5 that has another hint that I have to talk about that shows up sometimes. All right, but let's figure this out. So because the parenthesis comes last, even though there's a subtraction here and you want to try to get rid of it, it shares a parenthesis with your variable. So you're actually going to do that last. And so I'm going to start by getting rid of this 5. And I ask myself, what is the 5 doing to my variable? It's multiplying it, so I have to divide both sides by 5. So if you divide both sides by 5, you're just left on the left side with x minus 2 because the 5's cancel out, and now all you have left is that parentheses. And then on the right side, 25 divided by 5 is 5. Next, I have to think about this negative 2 that's sharing the parentheses with my variable. I can get rid of that by doing the opposite of subtracting, which is what it's doing to my variable, which is adding. So I add 2 to both sides. And when I do that, the 2's will cancel out on the left side, and I just have x left. And then 5 plus 2 is 7. And once again, they will have choices with purposeful distractors that are often the mistakes that people make. So you don't want to just jump the gun and assume that this is right, because it could be one of those distractor answers and you don't realize you made a mistake. To prevent yourself from doing that, actually plug in your number on the original expression on the side that has the x. So I've replaced the x with the 7 over here, and then I'll work this out. So this was the same thing as 5 times 5, which is, of course, 25. And that is the same thing I'm trying to get. So that is right. That is the option I want. I picked that option, and that's it. And the last hint that we have to talk about is this idea that sometimes there's going to be a fraction that you have to get rid of next to your variable. Like, for example, in this example, there's a 3/4 of x equals 12. To get rid of a fraction, the best thing to do, of course, is to ask yourself, what is it doing to my variable? It's multiplying it, so you have to divide both sides by it. Now, to divide by a fraction, it means to copy the first one, then dot, then flip. So that's the same thing as multiplying both by its inverse. So the skill that I use is to multiply both sides of the equation by the inverse fraction. In the case of 3/4, it would be 4/3 to cancel out the fraction, right? Because when you do 3/4 by 4/3, 3/4 times 4/3, they are reciprocals. So by definition, this is going to be 1. And 3 times 4 is 12. 4 times 3 is 12. That's 1. And so that is a step that you can do to get to the point where you have the identity property, and you can just cancel out that fraction from your expression. Now, you have to do that to both sides of the equation, right, in order to solve it right. There is an alternative way of thinking about this. If you're multiplying both sides by 4/3, it's as if you are first multiplying both sides by 4 to get rid of the 4 that's in the denominator, right? So it's dividing by 4, so you multiply by 4. But then you also divide both sides by 3 because you got to get rid of the 3 that is in the numerator, which is multiplying, right? So it's as if you're taking 2 steps at once, right? We need to multiply by 4/3. Or you can actually take one of those steps at a time too. So you can break it down and first divide both sides by 3 and then multiply both sides by 4 in order to get rid of that fraction. But I just like to remember, multiply both sides by the inverse of the fraction. So when you see a fraction in a problem like this one, it's 3/4 again, just multiply by the inverse of the fraction. So we already know that that's what we need to do. But the first step here is actually getting rid of this -26, right? Because you have to start with the reverse order of operations. And we do that by adding 26 to both sides of the expression. Since this 26 is subtracting, and I have to do the opposite to get rid of it. So if you do that to both sides, the -26 will cancel out on the left side, leaving you only with 3/4 of x. And then on the right side, -5 plus 26, they are different signs. So you're supposed to find a difference, which is 21, then keep the sign of the biggest, which is plus. So that means it's going to be 21 over there. Now, again, there's 2 ways you can get rid of this. You can divide both sides by 3 first to get rid of the 3 that's on the top, and then multiply both sides by 4 to get rid of the 4 that's on the bottom. Or, like I said, you can do both steps at once by multiplying by the inverse fraction of that 3/4, which is 4/3. But you got to do that to both sides of the expression. So when you do that, the 4/3, the 4 will cancel out with this 4, and the 3 will cancel out with this 3, and now you just have x on the left side, right? And then that is equal, you got to work this out. 21 divided by 3 is 7, times 4 is 28. Or you can do 21 times 4 and then divided by 3, but I like to divide first because it usually makes my life a little easier. There you go. I got 28 for my answer in just 2 steps by using that trick. And remember, once again, to plug in your answer on the original problem as if it was an expression to see if you get that right. So I'm going to replace the x on the expression with that 28, which is supposedly my answer, because I'm not trying to get cheated by the test and its distracting options. All right, so I do 28 divided by 4, which is 7. All right, so that becomes 3 times 7 minus 26. 3 times 7 is 21. So 21 minus 26. And that is -5 because their signs are different. I have to slash here and then change the signs. So I'm adding 2 different signs. So I'm supposed to find a difference between the numbers, which is 5, and keep the sign of the biggest, which is the -26. Happens to be negative. So that's my final answer. And it is what I was looking for. I was looking for -5. So that is right. And that, my friends, is how you solve equations with all the hints of things you are likely to see in this grade level. Okay. And lastly, I put some extra examples here on the screen of these skills in case you need to have more practice with this and to try to understand how to do it. And that's solving equations, objective 2. And the next one, we're going to be focusing on inequalities and how to do the same kind of thing with that. I'll see you guys then, my young Padawan learners.